Okay, very good afternoon. Today we are going to start actually the syllabus of unit number 1, that is an overview of an artificial intelligence. And quite interestingly, it is very much related to what we have studied in the last semester, and that is machine learning. So already I have said that okay, so this is the figure which actually gives you the complete idea about where the artificial intelligence stands. So you can come to know that there are three things in this, which first is a deep learning, the second one is a machine learning, and the third one is an artificial intelligence. Now, if you could look at this figure, which is nothing but a Venn diagram figure, in this actually we can see that deep learning is a subset of machine learning, whereas the machine learning is a subset of artificial intelligence. So you are starting from deep learning and moving towards the artificial intelligence. There is not much more a difference between machine learning and deep learning. As we know, as we can understand that actually machine learning is applicable only to those data which is small in number. So if you could see that the data set is a very small data set, then you can go for the machine learning. But if the data is very huge, very large amount of data is present, then we can go with deep learning. So deep learning can handle large amount of data. As you know that as we are living in an era where from all the sections, a huge and millions of trillions of data is coming, it becomes very much difficult to deal with this data, because huge amount of data is coming from all the sectors or from all the sensors. Actuators are playing roles, sensors are playing roles. So even in order to deal with these sensors, machine learning and deep learning will not be enough. You just need to have some kind of thinking. So when the human-like thinking comes into the picture, or human-like intelligence comes into the picture, then that is called as artificial intelligence. So you can see that deep learning, machine learning is applicable to small data, to the large set of data. But artificial intelligence, it is not just application to the data set, but it is about the thinking, which is like a human, which is mimicking of a human brain. So the human intelligence is nothing but it's a mimicking of human intelligence is nothing but artificial intelligence. So when intelligence comes into the picture, obviously the picture becomes very different, which is not as far as machine learning or deep learning is concerned. So I've given you just a broad way of how these three things are related with each other. There is one more factor which actually comes here is the data science. If you could just see that this is the figure here. Now, if I just want to place, somebody asks me where the data science will look like. So this circle will be like this. So this circle will be like this as far as the data science is concerned. So it will include all three. So that is called as the data science here. So this is deep learning, this is machine learning, this is artificial intelligence, and one more factor will come into the picture, that is called as the data science. Actually, data science is nothing but it is about the pre-processing of the data. Because what happens, uh, you don't know what kind of data is that. You need to represent the data in a very nice way so that it can be processed further. So at that time, to handle that data, you need to be very careful, because you don't need to lose very important data. Then you need to have all the features that has been required. You need to have a dimensionality reduction, which we have seen in the last subject, machine learning. So you should be able to do dimensionality reduction without losing much of the features. So all these things comes into the picture as far as the applications are concerned, and henceforth we have to take care that all these things all these things will be important as far as the applications is concerned. So machine learning, deep learning, and artificial. Now we have studied this machine learning. There is a deep learning part in your syllabus as far as machine learning was concerned. There also, and in artificial intelligence also, we have some part of deep learning and its application. But we are going to concentrate on this larger circle that is called as the artificial intelligence. So when artificial intelligence comes, I have said that human, it's like a mimicking human intelligence. This is like mimicking human brain, but this is like mimicking the complete human intelligence. So artificial intelligence, in order to study artificial intelligence, we need to know some part of deep learning and machine learning because there's a sub part of AI, right? So we will be having some part of deep learning. As we have studied machine learning, so nothing is about in this syllabus, but some part of deep learning is definitely there. Now, as far as this subject is concerned, they are much more concentrating on what is artificial intelligence, how does it work, and what are the application areas. The most important part is that it is not mm, like a machine learning subject where you have the whole idea about how actually what goes inside, but this is completely an subject of where everything is thought about how we look towards artificial intelligence in an application way. So there are different various applications of AI as well as applications of deep learning, and henceforth the subject name is given as artificial intelligence and application. That is what the important thing is about. So what is deep learning? It's a subset of a machine learning, which makes the computation of a multi-layer neural network feasible. What is machine learning? It's again a subset of AI, which uses statistical methods to enable machine to improve with experience. So as far as machine learning is concerned, I'll just make you recall what the definition was. Like if you want to learn the computer through, if you want to learn the computer through experience E, in order to perform a task T with the performance P, then if it's performance P for the task P, experiences improved, with experiences improved, it is called as machine learning. That's what we have studied about that uh, experience data. Data is nothing but experience E. Then you have seen what the task is, what the performance P is, measure is. So that is what the machine learning is. So actually it is dealing with the statistical methods to improve with the experience. And then the artificial intelligence, a technique which enables machine to mimic like a human behavior. So the intelligence and human behavior are very much related with each other. So how you behave is mostly because of how your intelligence is about. So this is what is the picture, a broader picture of the, I could say that Venn diagram of an artificial intelligence. So now we are going to see in next part as an what actually is the foundation part of an artificial intelligence. What is actually the artificial intelligence? What is the scope of AI? What are the approaches of AI? What is this artificial intelligence technique? So all these things will be covered in the first section of the unit number 1. So line by line, we will try to understand actually where this AI stands for. Since the invention of computers or machines, their capability to perform various tasks went on growing exponentially. So the computers came into the picture, and then the machines started coming into the picture, and the growth was exponential. It keep on increasing because the capabilities of machines and computers started increasing. Humans have developed the power of computer systems in terms of the diverse working domain, the increasing speed, reducing size with respect to time. So obviously, a lot of things have been worked as far as the computer systems are concerned. And now we are been dealing with a very high speed systems with reducing sizes. We are You can see that now what the TVs used to look like, what the computers used to look like, they are becoming thinner and thinner. And the reduction in the size and increasing in the speed with respect to time has moved the era in an exponential form. A branch of a computer science named as artificial intelligence persists creating the computers and machines as intelligent as human beings. So overall, what we are actually dealing with, this artificial intelligence is nothing but a branch of computer science. It is actually the basic branch of a computer science. And it's mainly used to mimic the human behavior, or it is usually to mimic the intelligence of the human being. And henceforth, the name is called as artificial intelligence. So I've already said that there are two things into picture. We have to consider two things. One is a natural intelligence and the other one is an artificial intelligence. So natural intelligence is the intelligence of a human, and the artificial intelligence is the intelligence of machine, right? So we are going to study the artificial intelligence, which is nothing but mimicking of a human intelligence. For any phenomena, you can distinguish real versus fake, where fake is non-real. You can distinguish natural versus artificial. Natural means occurring in the natural. So for any phenomena, you can distinguish between real versus fake, where fake is non-real, and you can distinguish natural versus artificial. So obviously there is a real part and there is a fake part. The fake is real, sorry, the real part is real, whereas the fake is non-real. Similarly, you can distinguish between natural and artificial. Natural means coming from the nature, and artificial means it's human made or a man made, which means made by the people. So this is what the word itself has a lot of meaning. According to the father of artificial intelligence, John McAfee, it is the science and engineering of making intelligent machines, especially intelligent computer programs. That was the John McAfee started, who is also said to be as the father of artificial intelligence. So he said that you have to make the computer programs as an intelligent program. So that means actually you are moving towards the intelligent machine. Artificial intelligence is a way of making a computer controlled robot or a software think intelligently. In a similar manner, the intelligent human thinks. So artificial intelligence is like it's like and controlling everything, like a computer controlled robot, which may be a software which is working as intelligently, doesn't have a mechanical part, and just a software which is thinking intelligently. And similar way, the intelligence, how the human thinks about. This is all about AI. I'm just introducing the AI, what it carries out. It's just not about the definition of what the artificial intelligence means. It is about all the things that we have been seeing around about the presence of AI. AI is accomplished by studying how human brain thinks and how human learn, decide, and work while trying to solve the problem. Exactly how human works out. If a problem is given to a human, how he works out, how he learns, how he decides, how he takes the decisions, and how he approaches to solve the problem. Exactly way the whole thing is been trying to mimic in case of artificial intelligence. And then using the outcomes of this study as a basis of developing intelligence software and systems. And taking this as basis, they have developed intelligence softwares and systems. The artificial intelligence or AI is the field that studies the synthesis and analysis of computational agents that act intelligently. Now, one word that has been very different and you might not heard about as far as the technical things are concerned is an agent, right? Now, artificial intelligence, we are going to study this agent. There is an intelligent agent, a robot agent, a software agent. Now, how this agent works out, we are going to see in the coming lectures. But it's very an interesting part, like how this agent works out as for this intelligence. And actually, the study says that synthesis and analysis of computational agents that acts on intelligence. Actually, the study of these computational agents, the analysis and synthesis of this agent is nothing but AI. So AI is defined in a very different ways. There are different ways of defining AI. So up till now, we were saying that artificial intelligence is nothing like human. It's like a human thinking. It's mimicking human intelligence. Now we are a little bit going further. Now we have been saying that it is nothing but the synthesis and analysis of a computational agent that acts intelligently. So this agent is nothing but a part of an intelligence. And if we are going to do the analysis and synthesis of it, it is called as AI. Now, as we know that what analysis is, it is about input and output. What is synthesis? It is about input and system and then studying about the output. Right? So analysis is I'm having input, I'm having system, and then I'm getting the output. But for the synthesis, I'm having input, I'm having output, and now I'm defining the system. That is called as the synthesis. So analysis and synthesis of a computational agent which are acting intelligently is called as artificial intelligence. So we are defining AI in numerous ways. And that's what makes it interesting. An agent is something that acts in an environment. It does something. Agents include worms, dogs, thermostats, airplanes, robots, human companies, and countries. So actually what this agent is, it is nothing but which is acting in the environment. Okay, these agents are acting in the environment. Now, as we go on, we'll come to know how actually agents works out to be. At this moment, what we'll see is that actually what this agent physically looks like. If I want to say that what is the agent? So it could be a worm, it could be a dog, it could be a thermostat, it could be a plane, it could be a robot, it could be human. Like what agent is about. Now this agent is the intelligent agent. Actually, intelligent agent, the name itself is saying, we normally say it to be as an agent, but it is an intelligent agent. So it acts in the environment. So this thing you just remember at the moment that it acts in the environment, and it could be of various types, which we have been seeing here. Exactly how it happens, you're going to see in the coming lecture. Okay. Now we judge an agent by its action. So as we know that agent acts in the environment. Yes, it acts in the environment. Now we are going to judge the agent by its action. It acts in the environment, and we can judge the agent by its action. Agent acts intelligently. So I said that the agents are intelligent agents. Normally we say it to be as an agent. Now, when it acts intelligently, that is the next part. So an agent acts intelligently when? What does it as an appropriate for the circumstances and the goals? When it's knowing that what are the circumstances and what are the goals it has to achieve. Second, it is flexible to changing environments and changing goals. So suddenly the environment is changing. So what agent will do? The goal is suddenly changed. So what agent can do? It has to act intelligently. There is no other option, right? So to act the agent intelligently, we are seeing these things. Intelligent agent. First, understands the appropriate circumstances and the goal. Second, flexible in changing the environment and the changing goals. Third, it learns from the experiences. Agents learn from the experiences. And the fourth, it makes appropriate choices given its perceptual and computational limitations. Even there is a limitations of perceptual and computational limitations are having with the agent. still it will try to make an appropriate choice. This is by far the most important concept when agent will be acting as intelligently. So that part is that to make an appropriate choices instead of having that computational limitation, even if it is having a computational limitation. So that is where the agent will come into the picture. I've said agent will act in the environment. Agent will be judged by its action. Agent will act as an intelligent in appropriate circumstances and goals, in changing environments and changing goals, from experiences, and also making appropriate choices instead of in even if it is having computational limitation. So this is all about the agent. So at least you might have got some idea of what the agent is. Okay. An agent typically cannot observe the state of world directly. It has only a finite memory and it does not have unlimited time to act. So there are some limitations of this agent. So obviously the computation limitation is going to be one of the most important limitations. Second is that it will not observe the state of world directly. It is, I mean to say, how to explain this one. Like it will be not directly connected to the world, what's happening around it. It has a finite memory and does not have an unlimited time to act. So that means it has to take action which can be judged, which has to be judged in a very limited time of act. It is not having unlimited time. We judge an agent by its action. An agent acts intelligently. A computational agent is an agent whose decisions about its action can be explained in terms of computation. So an agent is judged by the action, right? This is the line which is in there. It acts intelligently, it acts in the environment, and then it is judged. Sorry. And it is judged by its action. Now, when we say that it is judged by an action, what does it mean? What does it mean? It means how I am going to explain that I'm judging it through the action. Obviously, it is going to be explained in terms of computation. So your judging of the agent by its action is nothing but it is explained in terms of computation. Are you getting it? It's somewhat different. All the concept that is in there is different, but it's quite interesting, no doubt. Okay. Next, decision can be broken down into primitive operations that can be implemented in a physical device. So all the things that could be done in a computational way, the whole operations can be broken down, and then it can be implemented in the physical device. So first we are going to check it through the computationally, and then we are going to have then we can broke down into primitive operations which can be implemented in the physical devices. These computations can take many forms. In humans, this computations is carried out in wetware. In computers, it is carried out in hardware. So how this computation is carried out? Because see, when we say that I am judging the agent by its action, actually I am explaining that in terms of computation. So as far as the computation is concerned, it's a software thing, so which is also called as a wetware. But when we are converting it into or implemented into the physical device, then we say that it is carried out in a hardware. Because implementing computationally is somewhat different, and then putting into a physical device is somewhat different. They are two different things. So when we are doing computationally, that means we are judging the agent by its action. That means what we are doing is that we are dealing it with wetware. And when we are converting this whole computational agent computation in physical devices, then it is called as the hardware. So obviously there will be two parts in it. One is nothing but the computation, and the other one is nothing but the hardware. The other one is nothing but hardware. The computational part is also called as, which is carried out through wetware, whereas the physical or the computers, in computers, it is carried out in a hardware. So in human, if we say that I am carrying it out, the computation is carried out. If the computations, जैसे हम दिमाग में सोचते हैं और computations करते हैं, so in humans when we do it a computation and then it is converted into the physical action. So whatever you have been thinking, what you're calculating, what you're computing is converted into the physical action, and then somebody judges me by my physical action, right? Similar way. So in human, if the computation is been carried out, that is called as, that is carried out through wetware, and my physical actions, what the result is about the computation, then in computer it is called as the hardware. So wetware and hardware, these are the two concepts that comes in artificial intelligence. Now next, actually, what is the goal of an artificial intelligence? Because unless and until you have goals, not any concept can come into the picture. So obviously there are some goals of machine learning also. There are some goals of artificial intelligence also. So what these goals of artificial intelligence will be? So first is to create an expert system. So when will I say my system is an expert system? Systems which exhibit intelligent behavior, the system which can learn, the system which can demonstrate, the system can explain, and it also advise its user. तभी मैं बोलूंगा कि मेरा सिस्टम इंटेलिजेंट सिस्टम है, और या कहूंगा कि एक्सपर्ट सिस्टम, राइट? सो artificial intelligence can be used to create such kind of expert system. Second, to implement human intelligence in machines. So the second goal of AI is that why not to mimic the way human does? The human learns, the human studies, the human analyzes, and then human puts some goal and then achieves the goal. Human takes decisions. All these things, like behaving like a human, can be done in machines like human intelligence. So all the things which is not related with the human intelligence can be done exactly in machines. And that is what the goal of AI is. Third thing, the central scientific goal of AI is to understand the principles that make intelligent behavior possible in a natural or artificial system. So the main goal of AI is to understand the principles that make intelligent behavior possible in natural way. See, my behavior is a natural behavior. If I am teaching you, that's a natural way. I have learned, I have understood, I am understanding the things, and then I'm making you understand. This is how it has come. It is coming naturally. So similarly, if you want to implement the artificial intelligence, it should be naturally like human behaves naturally. Similarly, the way the natural intelligence performs, exactly the same artificial system should perform. And that's what the goal is about. That is central goal. Now, how it can be done? This can be done through the analysis of natural and artificial agents. So obviously agents will come into the past. How natural agents work? Like in me, there is some kind of agent, right? Obviously, see, if I am feeling very hot, very hot and humid, the agent analyzes this and it will try to make or try to um, take a decision that I should go in a cool place. So agent is acting on the environment and then it is responding. So we are judging the agent by its response. This is how it is happening. So how it could be? Obviously, the natural and artificial agents has to be studied. Without that, you cannot judge it. Second, formulating and testing hypotheses about what it takes to construct intelligent agents. Without hypothesis, you cannot do anything. We have seen hypothesis in machine learning also. Everything is hypothetical, and then it is converted into what the real thing is about. So formulating and testing the hypothesis, and then based on that, you're constructing the intelligent agent. That could be the thing. Third, designing, building, and experimenting with computation systems that perform tasks commonly viewed as requiring intelligence. Once you formulate, once you go for the hypothesis, the analysis of natural and artificial intelligence has been done. Then comes the designing, building, and experimenting with computational systems. Okay, so the scientific goal of AI can be achieved with the help of these three steps. The central engineering goal of AI is the design and synthesis of useful, intelligent artifacts. We actually want to build agents that act intelligently, and such agents are useful in many applications. So overall, what we are seeing that what are the goals of artificial intelligence? If you could revise, first is nothing but to create an expert system that exhibits intelligent behavior, learn, demonstrate, explain, and advise to the user. Second is making the machine think like human. Making means machine intelligence like a human intelligence. Creating the system that can understand, think, learn, and behave like humans. And the central goal of AI is nothing but to make the intelligent behavior as a natural behavior. How it could be done? Through analysis of natural and artificial agents, formulating and testing hypotheses to construct intelligent agents, designing, building, and experimenting the computational system that performs the task commonly viewed as requiring intelligence. And then ultimately, the central engineering goal of an AI is to design and synthesis useful, intelligent artifacts. So converting all those things into an intelligent artifact is the main aim. Example like robots. We can see that robots, how the computation is converted into the physical device. We actually want to build agents that act intelligently. Such agents are useful in many applications. So these are the goals of artificial intelligence. Next, what contributes to AI? Now, we have seen a lot of things about artificial intelligence, different ways of explaining artificial intelligence. Now, what are the parameters or what are the things that actually contribute to artificial intelligence? So these are the fields which are very common to make AI what the AI looks like. Is a philosophy, sociology, math, biology, neuroscience, psychology, and the computer science. Obviously, it is the field of a computer science, so obviously computer science is the main contributor in this. These are the various fields that will contribute to AI, and that's what it makes the AI. Artificial intelligence is a science and a technology based on the disciplines such as computer science, biology, physiology, linguistics, mathematics, and engineering. Everything is included as an AI. Since AI is a science and technology based on these disciplines. A major thrust of AI is in development of computer functions associated with the human intelligence, such as reasoning, learning, and problem solving. Now, when I say that human is intelligent, how you're behaving, how I want to, how can I say that a human is intelligent? Can anybody say? Yes. Hello, can anybody answer? Hello. Hello. Hello, please respond.
Yes, sir.
Can anybody say how you are intelligent? Okay, I will explain what actually it takes to say that human is intelligent. Obviously, if you go to a campus drive, if you go for an interview, they want to check technical intelligence as well as your logical intelligence. How it could be checked? It could be checked through reasoning, learning, and your problem solving ability. If you're good in this, then they say that is an artificial, then they say that this is your intelligence. Right. When we say that human is intelligent, obviously it's reasoning capability, it's learning capability, and the problem solving capability. If these three things are with the human, then I can say that human is an intelligent human. And that's why when you face interviews, they check your abilities, reasoning abilities, your learning ability, and your problem solving ability by various kinds of exams they check out. They test on basis of this. Out of the following areas, one or multiple areas can contribute to build an intelligent system. So obviously all these areas which are based on the disciplines of computer science, biology, and all those things. Your intelligence, or if you're going to build up an intelligent system, then one single can be a part of it, whereas all the things can come into the picture. So this is what the contribution to artificial intelligence is about. Okay, so we'll stop here. We'll go slowly because it will take a little more time to adjust. All these concepts are new concepts. So I little bit go slow some more so that you can understand bit by bit of this artificial intelligence subject. Okay, roll number, we'll start with A. Roll number 1.
Present, sir.
First of all, I'll